Hello friends, this video about Tower of Hanoi problem. I'm going to show the algorithm for Tower of Hanoi problem using small example and also large example with a 3 disk. Okay. Now before going to see about Tower of Hanoi problem, first we will see about what is recursion. Recursion, a function that calls itself during its execution. That is, it repeats itself several times until it ends the condition. It has basically has two cases. One is base cases and one is derived cases. The base cases means the terminating cases. Derived cases, it is an execution cases that it will execute again and again. And now we can go for a Tower of Hanoi problem. So the problem is there will be three pegs will be there. Peg A, this is peg A, peg B, and peg C. So you have to move the in peg A there will be a several number of rings will be there with increasing size. So you have to move this peg A rings to peg C using this middle ring. Okay. The only one condition is you should not keep the larger disk over the smaller disk. So this is the condition. And one more condition is there. At a time, you can move only one disk at a time. Okay. So the summary for, we can see the summary for the entire Tower of Hanoi. It can be solved by using recursion techniques, and there exist three peg. So peg A, peg B, peg C, as we see in here, this is A, B, and C. Several disks of different diameters, that is in increasing order, are placed in the peg A. So the larger disk is always below the smaller one. The objective is to move those disks to peg C using peg B. That is peg B as an auxiliary, that is temporary we can use. Only the top disk can be moved to the other peg, and at a time only one disk can be moved. Okay. Now we will see the solution for a different input. For example, if there is only one disk is there, you can take this example, solution for single disk. For example, only one disk is there, the solution is very simple. Move this peg A ring from peg A to C, that is move the disk from A to C, we solve the problem, that's all. Suppose if there is two disk is there, you can see here, if there is two disk is there means, so there will be a small manipulation will be there. So what type of manipulation means, you need to move that ring 2 is there, the ring 2 to B, then move the like this, then move the ring 1 to C. So it will be like this case, that is from A to C you are moving. Now you can move directly from B to C. You can see here, move your disk from B to C using A, that's all. So we have shifted everything. Now the problem is, if there is three ring is there, that is three disk is there. So now how we can do that, we will see step by step. First I will show the solutions, then we can go for the algorithms and step by step. So here the problem is there will be three peg is there, peg A, peg B, peg C, and we have three disks, and how we can move from A to C. So that we will see. Now we can see here, this is A, peg B, and peg C. So there is a three different color of ring is there. All are with different diameters. Purple ring, green ring, and some orange color ring is there. So now, what is the step one is move the purple ring A to C. You can see here. This is the first step. Move the disk from A to C. So we are moving from A to C. Then move from green color, move A to B, you can see here. Then move this from C to B, because it is smaller when compared to this B ring. Okay, then move from A to C. Okay, then move this B to A. Then move from B to C. Then move from A to C. That's all. So this is the overview. You can see here. I will enlarge it. So this is the given input. So the step one is moving from A to C, and A to B, then C to B. Okay, then A to C. You can see all the steps, different type of step is there. You can see that. Okay, now we can go for the algorithm. The algorithm is very simple, just 4 steps algorithm only. Suppose it covers all type of inputs. You can see here, to move n disk from A to C, that is from peg A to peg C, we are using a middle disk, middle peg as a B, that is auxiliary, that is temporary we are using. Suppose if there is only one disk is there, if n equal to 1. So what we will do, just simply move the single disk from A to C and we will stop the problem. If there is more than one disk is there, what we can do, that we will see now. Okay, suppose if there is more than one ring is there, so move the top n-1 disk from A to B using C, that is a B we are moving. Then we are moving the remaining disk from A to C. Then again we are moving from B to C using A as an auxiliary. Now we will see little bit enlarged. Okay, now you can see this diagram. This is the case. So now see here, we are declaring one function. So n is the input size what we are going to give, and string A, it is the peg A, peg B, and peg C. So this is source. String A is the source, and string C is the destination. String B is the auxiliary or temporary, you can say. Okay, so you have to move from string A to string C. So this is the thing you have to do. Now, if suppose I already discussed to you, if there is only one disk is there, if A equal to 1, okay, only one disk is there, that is the base case. Okay, so base case means it will execute this case and it will terminate. So move the disk from A to C and stop the problem. Else, if there is more than one ring is there, means you need to go in the recursion. So here the function name is Hanoi. Hanoi of n-1. So we suppose if you have 3, so here 2 comma A comma C comma B. So what is this? A means A is the source, C is the destination, that is a final destination we have to know, B is the auxiliary. Now the same thing we can see here diagrammatic view. Now this is the algorithm. You can see this algorithm. Okay, now we have 3 disks there. So now TOH is the tower of Hanoi. Tower of Hanoi, so n equal to 3, and 1 is the source, 2 is the auxiliary, and 3 is the destination. You can see this everything. Okay, now the first step is tower of Hanoi of n-1 comma A comma C comma B. So here tower of Hanoi of n-1 is 3 minus 1 is now you can see here the same thing we have written in a function, and for this function we have just elaborated how this function works. Okay, now n equal to 3 we have given. So here tower of Hanoi 3 comma totally 3 peg is there, 1 2 3. So you can see here 3 comma 1 comma 2 comma 3. So the 3 is the number of ring, 1 is the source, 2 is the auxiliary, that is middle peg, and 3 is the destination. So you have to move the 3 rings from 1 to 3. Okay, that is the thing. Now according to the algorithm, now first step is tower TOH, that is you can check this case. So n is greater than 0, that is 3, n equal to 3. So it comes inside. Tower of Hanoi of n-1 is 2. Okay, so 2, we are getting 2 here. So A is 1, so 1, C is 3, so 3, B is 2, 1 comma 3 comma 2. Okay, now we are going to this is the print statement, 1 comma 3. So here we are going to print this for this one and this one. So printing 1 comma 3. Then this side, so this is the thing, move a disk from A comma C, that is 1 comma 3 we are printing here. Now next step is TOH, the tower of Hanoi of n-1 comma B comma A comma C. So n-1 we know that is 3 comma B is 2 comma 1 comma 3. See here 2 comma 2 comma 1 comma 3. Okay, now again solving this term, now taking this as an input. So TOH of 2 comma 1 comma 3 comma 2 is there. So 2 is the input we are going to take. So now n-1 again if we take means n-1 is 1. Okay, that is 2 minus 1 is 1. So 1. So according to here A comma C comma B. So here this is A, this is C, and this is B. Okay, so here 1 comma 2 comma 3, and we are printing this 1 and this 2. Yeah, so this is print statement. Then again next step is TOH of n-1 comma B comma, that is a middle term comma source comma destination. So here middle term, here middle term is 3. So this 3 comma 1 comma 2. Yeah, exactly, we got it right. Now solving this term. So TOH of 2 comma 2 comma 1 comma 3 is there. So this 2 is the starting, 3 is the destination, 1 is the auxiliary. So now you solve by solving this one, you can first step is TOH of 1. So here 2 minus 1 is 1, comma. So what is the 2? So the 2 is the starting term, and C, next one is C is the this 3, and B is the middle term 1. So now we are printing 2 comma 3. So 2 comma 3 is printing, and going for the next this is a third step. So you can see for every function 3 step will be there. 1 2 3, 1 2 3 for this one, 1 2 3 for this one, 1 2 3 for this one, right? So similarly TOH for 1 comma 1 comma 2 comma 3 we are getting. Okay, now next term. So going from here, TOH of 1 comma 1 comma 2 comma 3 is there. I already told you if n equal to 1, just directly printing it. So here n equal to 1. So just print, move from 1 to 3. That's all, 1 comma 3. You can see that, right? Now here also n equal to 1. Move from 3 to 2. So 3 comma 2 it is printing. So here also n equal to 1. Move from 2 to 1. So 2 to 1. So here also n equal to 1. Move from 1 to 3. So 1 to 3. Now you just take all the printf statement so that you will get an answer clearly. So the first step is moving from 1 to 3. You can see this diagram. Moving from 1 to 3. So we have moved this green to here. The next one is 1 to 2. You can see this one. Only bottom you just see. 1 to 2 we are moving. So now 1 to 2. This blue color we are moving to B. So you can see this one. The next one is 3 comma 2. You can see here. Currently we are here. So we are moving from 3 comma 2. Yeah. So we are moving from 3, this green color to here. So this 3 comma 2 we are moving here. Now next step is obviously 1 comma 3. You can see here 1 comma 3. So we are moving this red color to here. The next step is we are moving from B, that is 2 comma 1. You can see here 2 comma 1. Yeah, we are moving this 2 comma 1. Then we are moving from 2 comma 3. So 2 comma 3 we are moving. Then finally 1 comma 3. So you can see this last of 1 comma 3. So just we are taking all the printf statement and we are printing here. So this is the final answer we are getting here. So that is the case I given here. Move this from A to C, that is 1 comma 3, 1 comma 2, 3 comma 2, 1 comma 3, 2 comma A, that is 2 comma 1, 2 comma 3 and 1 comma 3. So totally these are the steps we will cover. So this is Tower of Hanoi. It can work for any number of disks. Okay. So for one disk, it has separate cases. For 2 disks, separate cases. If it is more than 2, that is 3 disks, it has a separate cases. Okay. So this is very simple algorithm, and this is the explanation for this. This is the overall view of the diagram. Thank you, students. Thank you.